891, for each equation below, solve for W. If possible, show all work. Okay, so starting with A, I'm going to solve this using square roots. And because there's no W term, I can do this. So isolating W squared, I'm going to divide by 5 on both sides. And I get W squared equals 17 divided by 5. I don't want W squared, I want W. So I'm going to take the square root. If I take the square root of one side, I'm going to take the square root of the other. Because we want W to be positive, we know this value in here can be plus or minus the square root of 17 over 5. And so that's what we say W ends up being, plus or minus the square root of 17 divided by 5. And that's all under the square root. I should rewrite this. So you want to make sure the square root 17 divided by 5, that the whole number is under the square root. All right, in the second problem here, B, we want to solve this. I checked before to see if we could factor it. Obviously, that's the easiest way, but this is not factorable. So then we could use completing the square, but we have a coefficient, and these aren't factors of each other, and it's not an even number. So completing the square would be a lot of work. So I think the best method here would be the quadratic formula. X equals negative 3 plus or minus the square root of 4 times 5 times negative, oh, I forgot something here, big mistake. Remember, this has to be b squared, so negative 3 squared, and then minus 4 times 5 times negative 17, all divided by 2 times 5. All right, so now we get x equals 3 plus or minus, okay, what's underneath here? So this ends up being negative 3, or excuse me, yeah, negative 3 squared, which is 9, minus 4 times 5 times negative 17, which is 349, all divided by 349, all divided by 10. All right, if we could simplify this, the square root of 349, I don't know if there's any perfect squares that go in it. It doesn't look like it, but we can also give our approximate values. So we have x equals 3 plus the square root of 349 divided by 10, and so the approximate values would be 3 plus the square root of 349 divided by 10. So this would be 2.17, and then x equals 3 minus the square root of 349 divided by 10. So then 3 minus the square root of 349 and then divided by 10 is negative 1.57. Remember, typically when we're rounding these solutions for the quadratic formula, we usually do 2 decimal places. It's just something typically you see. All right, so now the last problem we have here, C, they want us to solve for 2w squared equals negative 3. And so when you solve for this, you divide by 2, and then we see w squared equals negative 3 squared. So in solving for w, I'm going to take the square root of both sides. So there are no real solutions in this problem. And they want us to solve for what w can be in this problem. And we can convert this to an I value, a complex number, but I don't think this problem is really asking us to do that, so I will stop at this point. So our answer is going to be no real solutions.